All right, we're back. We're still on page 79 of math analysis, and we are still solving trig equations, and we're dealing with like ugly angles, or I think of them as ugly angles, because they're not the famous angles, so you don't get a famous ratio, so you got to do other stuff. And your answers tend to look kind of crazy when you write the exact values, right? So these are our exact answers to the previous problem. Then the approximations also like don't look that great because they're going to be decimals. We're going to go 3 decimal places unless otherwise stated, which it almost never is. So always 3 decimals. So let's see if we can solve this. So cotangent, we were having technical difficulties last time. I was going to try to do this in the same video, but I couldn't get over the notes. But we're here now. So cotangent of x equals 9.843, and we want to try to find x. So I'm going to start off the same way. This is basically the same problem. A, S, T, C. So where is tangent positive? That's here and here. So I'm going to need a reference angle. So reference angles always do the inverse trig whatever of the absolute value of the ratio that you're given. In this case, the ratio is positive, so not actually relevant, but still. And I'm going to call it x prime this time. I called it x hat last time. Will be the inverse cotangent of 9.843. And now we need to actually write down our angles. So we need quadrant 1 and we need quadrant 3. There's some stuff to talk about here. So one option is to say in quadrant 1, okay, so let's actually just do it. So in quadrant 1, we're going to get the x, the angle, not the reference angle, is just the same as the reference angle. So it is cotan inverse of 9.843. And that's fine. In quadrant 3, right, so you go pi and then you go more. So it's going to be pi plus the inverse cotangent of 9.843. Okay. So far so good. Now the exact answers, right? You can go all the way around the circle. Let's do that first. So for quadrant 1, if I go all the way around, just keep going coterminal, it's going to be x equals cotan inverse 9.843 plus 2 pi n, where n is an element of the integers. And then in quadrant 3, same deal, basically. It's going to be pi plus cotan inverse. So this is the reference angle. And then plus 2 pi n, where n is an element of the integers. Then we can get approximations for those. But what I want to do is I want to stop and think for 1 second about the relationship between quadrant 1 and quadrant 3 when we have the same reference angle. So if we draw a slightly bigger, maybe slightly better picture, we're going to have go vertical, horizontal rather. Is it because I said the wrong word that it doesn't want to do it? I think maybe it did. It's really hard to say. All right, so I'm going to draw a line that goes through the origin. So this line right here, this is our reference angle, and it's the actual angle. This is also our reference angle. It's not the actual angle because the actual angle is pi plus the reference angle. But look what's happening here. If I start at this and just add pi, it'll take me to the other angle that I get. If I then add pi to that, it'll take me back there. If I add pi again, I'll be here. If I keep adding pi. So actually, what I could do is I don't need both of these. So I don't need both. Because you either need both, or I could just write x equals cotan inverse of 9.843. 9.843. That's our reference angle. Plus, instead of 2 pi n, just add pi times n. Pi times n, where n is an element of the integers. So I could do this instead. And what I'm telling you is you can do either or. I don't really care. I mean, this is more efficient to do one answer that gets all of them, but it's more like consistent with how you're learning to do two. I don't know. You could do one or you could do both. It doesn't make a difference to me. But you either are doing both of these or you are doing just this. There's not like a mix and match. So approximate solutions, we need a calculator. So I'm going to go to the calculator. Hopefully it lets me come back. We had an issue last time where I was unable to return to the notes. So I'm going to do arc cotan of 9.843. And then I'm just going to do the pi n one times plus pi times n, control enter. So I get x is, I'm writing this in the notes right now. So x is approximately 0.101, 3 decimals all the time, and then plus 3.142, I guess, times n, where n is an element of the integers. It's hard to check these kind of, well, not impossible. So cotan of x such that, you know, I mean, like you just basically know that this is definitely right. Arc cotan of 9.843, like definitely works because we're supposed to get 9.843. And if I add pi to that, I still get that. So it definitely is working. We can also use solve. Solve. Cotan of x equals 9.843. Solve that for x. And it gives us this. So it's going to give you decimals because if there's decimal anywhere in the problem, it always gives a decimal back as the answer. So tangent and cotangent, because the period is pi, are a little bit different. Like you can generalize in one shot rather than needing two different things. It's just something to be on the lookout for. So let me try to get back to the notes. Hopefully I can. And if I can, we'll take one last look at it. So the difference is this over here, right? This picture, because the angles are they're vertical angles. It's because the quadrants are like across from each other where things happen, right? For sine, it's like you're here. For cosine, you're here or you're here. I should have said for sine, you're either up here or you're down here. Tangent and cotangent, it's not the same, right? You get ASTC, so you're either doing this or you're doing this. But if you do this, then it's plus pi, plus pi, plus pi. And then, so you only need one equation. So it's a little bit different, a little extra thought process. But again, if you do two, I'm okay with it. If you're not in my class, your teacher might not be okay with it. I'm okay with it. It doesn't bother me at all. So I'm gonna end this video here, come back in the next one, do some more. So I will see you there.